Let's let B be an element of R 1 by n. Then B can be written as a linear combination of vectors, and this is where things are going to get a little bit crazy.
Oh yeah.
Because how do you, you have to do something a little different here. How big is B? 1 by n. If I was thinking about writing a 1 by n in terms of vectors, could you guess how many vectors I'm going to use? M of them. Which ones would they be? And this is where I want to use actually y's. Y sub I times what? Yeah, and this is where really we should put like a hat. Why am I putting a hat rather than a? I don't even know what notation I should use. Maybe some Japanese. Ah. Or alpha? No, alpha shouldn't. A smiley face? Yeah, okay. So you think it's okay I do that? Is this the same vector that I had earlier? Is this vector the same one as my other A1? No. Why not? It's a row vector. Okay, what's the next one? Y2A2. And this is now a 1 by n. And I keep going until I hit what? Ym. AM. And this is going to be what? 1 by n. I'm so happy we're doing this because I think this is, I've thought a lot in my life, way too many hours, about the following questions. Why, oh why, do linear algebraists prefer column vectors? Not a single person has ever said, this is why we prefer column vectors. Well, actually it's not about saving space. How do we write? Do we write this way or this way?
Our papers are with lines, so it would be easier to write than yours, technically.
But how much space do you have, right? Right? Yeah, that's one reason that I think that's true. There's another reason, and we'll talk about that in a bit. Yeah.
You can try organizing them like putting like you do long addition, like put one then put.
Yeah, but I want to show this because you will see that we deeply prefer column vectors in linear algebra. It's something that, the column vectors are the only ones you're allowed to not specify the number of columns, right?
That's right.
And like generally it is very, very standard in most linear algebraic texts that unless there's some compelling reason, work in columns. And that's bothered me. Like, why don't row vectors get the same love, right? All row vectors. Yeah, that's right. Well, that's actually not true. there are different row vectors in life, right? But the sentiment I definitely agree with, right? Okay, so could you guess what this first one is? 1, 1, 1, 2. Yeah, all the way down to 1n. And then what? Plus y2 a2 1 2 2 all the way down to 2n. And then I just keep going until I have y m, and then what? m1, m2, all the way down to mn. Could you write this as a linear combination of the rows of A using colon notation? What would that look like? Yeah, the way I would say that is the first row of A. So y1 times the first row of A. And then of course, the thing I'm going to advocate for is always to write the dimension. Now what's next? y2 times the second row of A. All the way down to what? Times the? Okay, now I'm going to challenge you. Write this as a matrix vector multiplication for yourself. Let's see if anybody gets caught in the trap. Anybody got caught in the trap? Anybody do this? Anybody do that one? What would it be? Y on the left, matrix on the right. I'm going to make a request of you. We have such preferential treatment for column vectors, we're still going to think about y as a column vector.
What?
Yeah. I want you to be mad about this. I want you to write your senator and say, Senator, row vectors need equal representation under the matrix operation. Is this the same matrix vector multiplication function? Say no. What's the other matrix vector multiplication function? Where's the matrix? Where's the vector? Matrix is on the left, vector's on the right. You might call this the bizarro world function. What goes in, what comes out? Yeah. Well, in this case, I'm going to actually put the y transpose in. You'll see this is a little bit frustrating to me. Why mathematicians are like predisposed to use column vectors, and so generally when you multiply a vector on the left, they want to know that that thing is a row vector, and so they'll put a transpose because if not, it's assumed to be a column vector. Yep.
Why can't you put the vector on the left to inner dimensions agree? Because it's 1 by m and then m by n. So
Inner dimensions don't agree on that one.
the m's.
That's called not. Okay, so here's a question for you. Just spatially speaking, think about where's the inside of this operation?
No, I'm talking about the original y, not talking about the transpose.
Oh, this one?
Yeah, that has 1 by m.
Oh, you could write that as a 1 by m. Yeah, yeah.
And then you could do the whole.
Yep, that's right.
And then you're
Wouldn't that make sense? Wouldn't that be cool if people did it that way? We don't do it that way. Okay, do you want the real truth of this? This comes from quadratic forms, okay? What you're actually running into right now, there's a very, very famous thing in life called quadratic forms. They're a way that you can bring in linear algebra to quadratic space. In fact, least squares is based on quadratic forms. Semi-definite programming is based on quadratic forms. Quadratic forms show up in many, many places, right? In quadratic forms, the thing that you multiply on the right should be the transpose of the thing that you multiply on the left. That is a huge study in linear algebra. It's a subfield of linear algebra that shows up all over the place. Formally speaking, I think the reason that linear algebraists put the transpose on here is because it's training to make connections between the left part of that operation and the corresponding theory in quadratic forms. So this is actually prep work for that. For our purposes today, I could have avoided this whole conversation and just say, oh, let this be a row vector. But the moment that I do that, then I'm getting into the process of saying some of them are row vectors, some of them are column vectors. And the moment that I do that, later in the course, I'm going to have to correct myself.
Yeah.
So from that, and we actually probably won't get to quadratic forms this quarter. That's an advanced talk. I think we should be able to get to it. It's ridiculous to me that we teach least squares without talking about quadratic forms. That's stupid. But they give me 1 quarter, so in 1 quarter I'll do the best that I can, and I'll keep it basic, right? Yeah, so what was the answer to your question? Yeah, and that's training for something a little bit more advanced than we need to go to today, right? But you're right, formally speaking. So what would this matrix vector multiplication be? It would actually be a vector matrix multiplication. Where would we come in? Where would we go out? So if we think about F bizarro, what's the input? What's the output? 1 by n, and the output is the input's a 1 by m, and what's the output? Do you notice something interesting about that? Let's go back to the regular Superman world. What's the input?
R by
n by 1, and the output is a
n by 1.
Do you notice something? They're not inverses, though. They're not inverse. Taking linear combinations of the columns is not the same thing as taking linear combinations of the row, unless the matrix is symmetric, which is beyond me. Right?